So I'm going to be giving a presentation about the name of the title, right? So like the future of digital identity. So I myself, I go by dcbuilder on Twitter or X and other places. Essentially, I'm a research engineer at the Worldcoin Foundation, where I mostly work on our grants program, where we give grants to different people working on different problems within the Worldcoin ecosystem. So things like research within cryptography, protocol design, lots of other things. And I've been working or at least on Worldcoin for the better part of the last 2 years. And during that time, I've just spent a lot of time in the general digital identity ecosystem. And of course, as a user of like the web for the last 20 years of my life, I've also experienced like what the current status of digital identity is and sort of where we're trying to go in aligned with our like cypherpunk values as a crypto ecosystem, right? Like how do we make this privacy preserving? How do we make this decentralized? How do we make this in a way where users are sovereign, et cetera, et cetera, et cetera. So this is essentially what my talk is going to be about. So I want to start with sort of like where we are today, right? Like the status quo where we are today is extremely painful, right? We just share our data to everyone. Why is it not? Okay, there we go. So essentially the current status of things is that all of our data is owned by big centralized agents or entities and companies like Google, Amazon, Facebook, Meta, like all these companies essentially own all our personal data. And essentially we sell our data in exchange for free services. And then they monetize our data and sell their data to third parties, so they're able to do better advertisement targetings or product placements or essentially all sorts of other things where they leverage our personal information in order to sell products, so they're able to serve us their products for free, like social media networks, search engines, etc. So essentially the status of things right now is that everything is in siloed databases around the world in servers, our personal data, as opposed to in our own hands, so we don't really have control over it. It's permissioned, right? So let's say that I'm a YouTuber. If I'm a YouTuber and I create content for a living, let's say I spend like 5 years creating content, I get like, I don't know, 5 million subscribers or 1 million subscribers, whatever, and it's my livelihood. If Google or YouTube at any point in time, they decide to just censor me and cancel me, I lose part of my identity. Like I lose the network of sort of subscribers I've built, I lose everything about myself, what that defines me sort of in a way, because it's something I put a lot of time into and it's sort of part of my identity. It's not interoperable, right? So like my YouTube account means nothing on Facebook, or my YouTube account means nothing on Twitch, means nothing anywhere else. I'm not able to export my data, I'm not able to use it elsewhere because it's separate databases. I'm only able to use like my specific identity within the platform that I'm in, but my identity is not sort of interoperable across platforms or shareable or essentially composable. It's secure in a vulnerability to have all of my data on secured, like some distributed servers, etc. Right? Like we've seen like Cambridge Analytica, where Facebook data was published, and a lot of that ended up being leaked on the internet, so people could extract our phone numbers, addresses, essentially virtually doxing like millions of users, etc. It's privacy invasive. It's a bit self-explanatory. KYC doesn't scale at large, right? So like KYC, for example, works within one specific country. There's many countries that they cannot even trust their own governments and the documents that they issue. So that part of digital identity, like the physical identity that we use for using our services day to day, they don't scale for like the global side of things. It's centralized, meaning that there's some entity or some individuals that have control over our data. And we lack user sovereignty, right? Like we as users have no say into this. Like we just accept terms of service, we don't read them, we don't even know what's in there, and then we ended up getting sued for like violating one of the clauses that we haven't even read. So essentially where I want to go with this is that in the last couple of years there's been a lot of new developments in cryptography. There's been lots of new primitives that have come out. And these sort of allow for a new world of sort of development possibilities in terms of the applications we can build to give power back to the user. Cryptography or asymmetric cryptography gave us back power because we were able to build decentralized distributed systems like Bitcoin, and now we're able to own our own assets, and it's secured by cryptography, right? Like it's giving back sovereignty to the user. But this has been happening with money, with DeFi. It's been happening with maybe with art, with NFTs to some extent, but it's not really happened with digital identity. We still use the same services. We still don't own our data. So this is sort of like where I want the world to go next, and these are sort of some of the, oops, it skipped too much. So these are one of the, or at least a few of the cryptographical primitives that would allow this. So many of you, who here has heard of ZK? I presume most of you have heard of zero-knowledge cryptography at one point. Okay, maybe not, okay. So zero-knowledge cryptography is essentially a way that allows you to make a proof without revealing necessarily information you don't want, right? So in the context of zero-knowledge cryptography, there's usually a notion of a prover and a verifier. A prover can prove a statement to the verifier without revealing the necessary information or all of the information to the verifier. So to just put this into perspective, I'm able to prove to all of you that I'm over 18 without revealing you my true age. And that's just through like making a proof where I'm able to essentially commit to the data that I'm putting in. Like let's say that the data comes from like some signature on my personal digital identity from the government, and I'm able to verify that signature inside of ZK, and then I'm able to make a statement like, hey, age over 18, and then I'm able to create a proof. And you as a verifier have a cryptographic guarantee. You can mathematically verify that I'm indeed over 18 without me actually, or without the verifier or you in this case learning my actual age. So essentially I'm able to prove statements about some personal information to someone else. FHE, or fully homomorphic encryption. Whoops, we lost the visuals. No worries. Yeah, anyway, fully homomorphic encryption essentially allows you to encrypt data and perform computations on encrypted data as opposed to perform operations on unencrypted data, right? Normally, when you encrypt something, you lose all information because it's indistinguishable from random because it's encrypted, right? But fully homomorphic encryption allows you to encrypt some data. You can perform the operations on that encrypted data, and when you decrypt, it's as if you had performed the operation on the unencrypted data, which feels like magic, but essentially allows us to do privacy-preserving computation without the person performing the operation ever learning the information that it's performing the operation on top of. Another one is multi-party computation. So multi-party computation is a way where we're able to distribute computation across a set of participants in this case, and these participants essentially never learn the things that they're essentially computing over, because you can have it in sort of like a secret sharing scheme. So you're able to essentially encrypt, and you're able to perform operations on top of this encrypted shares. And when you add these encrypted shares together, it's as if these like multiple participants have computed the operation together. So essentially you're able to do shared computation across multiple parties without revealing the computations or the data you're making the computations on top of. And the last one is TEs, or trusted execution environments. So trusted execution environments are a piece of physical hardware. This is not cryptography per se. They do use cryptography, but it's essentially a type of hardware that allows you to prove that some computation happened on the actual chip, right? Usually when you're using a CPU or a GPU, it doesn't give you a proof of anything. It just computes it, and you trust that the computer did it correctly. And if it did incorrectly, then you have to debug it, etc. Essentially, trusted execution environments attach signatures with the computations they perform, so they're able to verify that, hey, okay, my computer calculated that the 10th prime is whatever, right? Or that's any computation, essentially, that you want to imagine. So these 4 types of cryptography, or 4 types of new primitives within cryptography, allows us to do lots of new things. Some of which are the following. So essentially these are new protocols or mechanisms that allow us to make proofs or statements about all sorts of different data in a way that is privacy preserving, right? So I list things like ZK email, ZK login, proof of personhood, ZK KYC, co-processors, etc. I really recommend you read the original article, which I'll have a QR code towards the end, but to sort of give you a notion of what these mean. So for example, ZK email, right? All of you have used email, I presume, like that's something that I can assume, that everyone's used email sometimes, or at one point in their life. So essentially emails, they come from some server, right? Like I own a domain, right? So let's say that I create a gmail.com email, so that domain is owned by Google, and I can own one subsidiary within that, so like my personal name, whatever, dot my last name, at gmail.com, for example. Google servers sign every email that you send, and you're able to verify that signature. And using zero-knowledge cryptography, I'm able to create a proof that something actually came from someone, and that some email contains some information. So for example, using ZK email, people have built peer-to-peer exchanges, where I'm able to verify that, for example, Venmo, I've received money from someone on Venmo, and if someone proves to me that I've received money on Venmo from them, then they can claim money from a smart contract, for example. So you can create decentralized order books based on emails, for example. This is just one example, but you can make arbitrary proofs about email information in a way that is privacy preserving. So this allows you to sort of make statements and proofs about personal information as well. So essentially where I want to go with this is that now you have a notion of data your own personal information or data or anything that you've ever had in terms of on your computer, and you're able to sort of prove where it came from. I can prove that my data came from Facebook.com because you can do a ZK-TLS or TLS notary attestation, right? I can prove that it came from the blockchain by proving a storage proof. I can prove that it came from my KYC, like my I don't know, my digital identity or my ID card by verifying a signature from the government authority and then doing a ZK attestation. Essentially, we have a notion of data and provenance proofs. And once we sort of take this data and these provenance proofs, we can put them in a general computational environment. I don't know, how many of you have used any ZK rollup? Any L2, ZK-based L2? Okay. Essentially, we have these like general programmable environments that are provable, right? In the context of Ethereum scalability, we use them to sort of prove that one computer performed a set of operations and updated the state of the Ethereum node correctly, and then you're able to, everyone else on the network can just verify that proof as opposed to recomputing everything, right? I presume that you guys are mostly from Polkadot, Sui, and Near, and other ecosystems, but essentially the notion of distributed systems is the same. Like all computers just verify the same like transactions happened correctly, and then they update the state in unison. But this is very expensive and very burdensome and slow. So with ZK, you're able to just perform the computation once, prove it, and then verify it equally across everywhere else, and it saves a lot of things. And so essentially with ZK, like, or these programmable environments, we're able to essentially make statements about our personal information. So I'm able to prove to you that, hey, I'm a unique person verified by Worldcoin, and I am over 18, and I've listened to, I don't know, more than 100 hours of Tupac on Spotify, or whatever. Like, I'm able to make arbitrary statements about my personal information without revealing any of my personal information to you, or without any third party owning my data, in order for them to trust me that I actually have done so, such and such things. Because we have a notion of where the data came from, because we have attestations that, oh, this came from Facebook.com, this came from Spotify.com, this came from the blockchain, this came from whatever. We can verify these cryptographic proofs, and we can make statements about them. And these sort of mechanisms are different things that we can use to sort of expand the notion or the things we can build with digital identity protocols and primitives. So I think since the audience is not mostly technical, we can probably skip this set of slides. Essentially, this is sort of like how I envision all of these technical components getting together or getting put together. You have some notion of data and provenance proofs, you put them in a programmable environment, you make an attestation, and then some application or some consumer at the end consumes these attestations, and you're able to sort of use it as a just general purpose digital identity protocol. So in the future, I want to get to a point where we've moved away from the current status quo to sort of like the values that we embody within the crypto space, right? Something that is decentralized, like my personal information is sort of only owned by me, but I have access to essentially any other service because nothing is gatekeeping me from it. Like if I want to use a decentralized social media network, I can use it, and people can, for example, curate it at the front end level, but the actual information can always be queried by anyone. It's self-sovereign, right? I, as a user, actually am able to use it, and I can use it on my own terms. I don't have to accept some weird third-party like terms of service and me not understanding legalese, because who the hell is gonna like read 20, 30 pages of legalese, like legal terms, and me not understanding anything what I'm signing. Privacy preserving, right? I own my own personal information, and I'm able to make statements about it, and I'm able to selectively reveal whatever I want to without compromising my personal information. But also the applications I use are much better than the applications I use today. That's the only problem that we have nowadays, because most of the people in the world, they don't care about anything. Like they don't care about, oh, Google has my information, Facebook has my information, whatever. We just use these services because they're convenient, they make our lives better and easier. And that's fine for 99% of the world, but there needs to be a sort of subset of the population that actually cares and creates better services than the ones that we have currently, but ones that are privacy preserving by default. So also scalable, right? The problem of ZK and all of these new fancy types of cryptography is that they're slower than just not doing any cryptography, right? So if you don't do any cryptography, you can have faster applications, more smoother user experience, etc. So we need to do a lot of work in the decentralized setting to make it as fast or as sort of convenient and as usable, especially for developers, right? Like developers need to have as the less friction they have, the better applications they're able to build. interoperable and composable. So as opposed to just having one centralized database that like you can use within like one specific part of the internet, you can have composable and interoperable protocols. So like my social media profile in a decentralized social media network can be composable with the marketplace. It can be composable with, I don't know, like my personal banking. It can be composable with whatever. Because it's just cryptographic proofs at the end of the day, and cryptography is composable and malleable, because at the end of the day it's just data and statements about that data, and people, if they're able to verify that that data is trustworthy, or it came from a specific place that is trustworthy, then we can sort of build applications around that in a decentralized setting. Incentive aligned, so I can, 5 minutes, okay. So incentive aligned, so essentially nowadays, we sell our data to third parties. We don't even know how much money they make off of it, and we just use their services for free. But we're on the we essentially take the short stick, right? Like out of everyone else. The companies benefit off of us. We don't make anything, and there's no incentives for Axe to actually create content or whatever. Right? Like YouTube makes a lot more money from your content by selling ads than you from being a content creator. Of course, they provide the infrastructure and all these other things, which are really expensive. They need to pay people, etc. But in a decentralized setting, you're able to just have decentralized infrastructure, and all of the developers and the users can be paid in a transparent way and fair way that people can actually agree on without you actually having to sell your personal information to them. And open source and community built. Of course, like all of these companies, all of their software, all of their technology stacks, all of their servers are closed source, private. You don't have access to them. And so you don't really know what is happening in the background. The systems that we should use should be resilient, open source, and community built, so that if, let's say, there's a new feature you want to build for whatever the thing that you're using, you should be able to build it your own yourself. And like, if you build it, you should also get rewarded for it, right? So there should be like these decentralized communities. Like this is what we're doing with Ethereum, with Solana, with all of these like L1s, L2s, et cetera, like scalability solutions, and all the things that we're building in crypto essentially are this. Like open source, anybody can audit the code, anybody can verify that it's running correctly, it's transparent. Of course, we're also building privacy tooling, like privacy preserving blockchains, privacy preserving digital identity protocols, et cetera. But it should be open source and community built by default, as opposed to corporate and privacy preserving. Okay. So if you want to ask me any questions, if you like forget anything or you want to ask me questions, I have my X profile and Telegram. My handle is @dcbuild3r, and the link to the full article that I wrote last year in December or November and published in December can be found on my blog at dcbuilder.eth, or if you want, you can also scan that QR code. Okay, thank you very much for listening, and if you want to ask me any questions, feel free.